Masechet Eruvin, Daf Nun Vav. We are starting with a couple of agadot, just some health advice, and then we're going to be getting into a section about astronomy, really quite interesting about how to find due north if you're out camping and you don't have a compass with you. So this could be actually useful in case you're lost somewhere, and then some geometry about calculating the corners of the field and turning a circle into a square. We'll get a good sense of how the rabbis did their math as well. All right, we start with Agadot. Amar Rav Huna kol ir she'en bayarak and tamid chacham rashai la'adur ba. If a sage doesn't have vegetables, then a sage should not dwell there because he doesn't have that good healthy food that would keep him well. This seems to imply that vegetables are good for you. However, there's a braita that says there are three things that increase one's waist and makes a person hunchback and removes 1/500th of the light of someone's eyes. It doesn't sound like very much, but still, I guess you'd rather not have that. And this is coarse bread and new beer that hasn't fermented sufficiently, and vegetables. So there you go. See, vegetables are not good for you. This is a good source for every kid out there, right? Who doesn't want to eat their vegetables? Just quote this baraita. So we have a contradiction because it says the sage should live in a place where there are vegetables, and here it says vegetables are bad. Depends what vegetables. Garlic and leeks are good for you. Other vegetables are not. I'm not sure why they thought the vegetables were not good. Maybe they didn't have pesticides, and maybe they had diseases in them. I'm not sure what kind of things they were growing and what their state was. We have a braita that backs this up, that garlic, that's a healthy vegetable. And leeks are a half healthy vegetable. And if you see a radish, that is medicine for life. Okay, so we didn't even mention that, but radishes are good. Now, regarding radishes, if you see a radish, that's a lethal drug. Last is contradiction. Depends. Talking about the leaves are not good for you, but the bulb itself, the roots are good for you. Can be motachama, can be motageshamim, or another answer, depends on what time of year. During the summer, they're good. During the winter, they're bad. Sinon is the same word as sonen, which means cold. So if you have it during the winter, it's going to make you cold, and that is not good, but it's good to cool off during the summer. All right, that ends the health advice. And now we get to figuring out some astronomy. Oh wait, still some health advice. Any city that has a lot of ascents and descents, if it's built on the side of a mountain, or a lot of Jerusalem is like this. So people and animals die half their lives because they're giving so much energy walking up and down all of their lives. Hold on, you mean they really die prematurely? It's a little extreme. Rather, that they grow old sooner. This is, I guess, appropriate. Today's my birthday, so. And these two sages say, in fact, that the ascents and descents of these two cities where they lived made them grow old early. All right, now we get to astronomy. When you have a circular city, and we learned that when you make the techum, first you turn it into a square, and only after that, let's see a picture. Right, you have a circular city. First, you square out the edges, and only from there, you measure 2,000 amot in every direction as the Techum Shabbat. So you gain a little extra space, especially on the diagonals. So when you do this, since it's circular, you can make the square on any axis point. So it's saying that the axis point should be due north. In other words, according to the compass. If a city was already square, then you wouldn't have to do this. We saw that in a previous stuff. Even if it's like a diamond, so it's off the axis, and then you leave it just as is. But if it's circular already, and you're coming to square it off, it should be due north. Okay. Now, so you put the top of it to the north of the world and the bottom to the south of the world, the southern part south of the world. Simanech agala besafon ve'akra bedarom. And if you need to figure out where north is, well, just look up at the night sky and you'll see that Ursa Major is to the north and Scorpio is in the south. Ursa Major is the Big Dipper and the Little Dipper. The North Star is actually part of the Little Dipper, which is quite noticeable. And so that you'll know is north. And Scorpio is more or less due south. And so just look for those constellations and you'll know which way it is. All right, that's good. If you don't know how to do that, you're not familiar with the constellation sufficiently, then you figure it out based on the tikufa, based on the seasons. How so? So on a long day, in other words, in the summer, you look at where sunrise and sunset are, and that is the north. In other words, during the summer, since the axis of the earth is leaning towards the sun, so as long as you're in the northern hemisphere, the sun is going to rise and set north of the horizon. The northern side, I mean, it's on the east and west, but it'll be the north side of the east. And so you can tell that that is north. If it's a short day during the winter, then the sun rises on the eastern horizon, but on the southern side of the horizon. So you just look and you'll see that and you'll know that that is due south. And during the middle, during the equinox, in the fall and the spring, or spring and fall, then it rises exactly in the middle. So then you know that wherever it rises, that's exactly east. And then you can figure out from there what the north and south are. So good, that's a second way to figure out the directions. How does he know? He actually has a proof, Shne'emad, from Kohelet. That's very appropriate to quote Kohelet on Sukkot. That's the Megillah for Sukkot. Shne'emad, Holech el darom v'sovev el safon. Says the sun rises and sets. It goes south and it turns about north. So you see that the sun is moving south and north. Holech el darom bayom sovev el safon balayla. So that would mean during a shorter day it would go to the south during the day, and then at night it will come back on the other side of the earth in the northern part of it, which is correct. Sobev holech haruach elu penei mizrach upenei ma'arav pamim halachtan pamim mesabebatan. The rest of the pasuk talks about how sometimes you can see the sun, and sometimes it traverses without being seen when it goes behind. And so that's a proof that the sun moves sometimes more north, sometimes more south, and we can use that to tell which way north is. Very interesting. Rabbi Shashia says we reject these proofs. If you remember, a few dapim ago, Rabbi Shashia said the same exact words, and that was regarding the klale pisika, when we say halacha kedebi yoseh mechaverav and so on, and that was a long proof. And Rabbi Shashia says no, we judge every case on a case-by-case basis. We don't use these rules, these meta rules, and so it's exact same words. And so I wonder, did Rabbi Shashia say the same exact words regarding halachic psak and regarding astronomy, that we reject both rules, or did he say it on only one place, and it's the Talmud that applies it to the other place? It seems to me that it's more germane here than there, but you could argue the other way too. Okay. Detanya lo yasa chama me'olam mekeren mizrachit tzefonit v'shak'a bekeren ma'aravit tzefonit v'lo yasa chama mekeren mizrachit deromit v'shak'a bekeren ma'aravit deromit. And the reason is because the Braita, he says that, because the Braita says the sun never came out in the absolute north eastern corner. And it might go up north a little bit, but it's not coming from all the way in the corner. So therefore, you can't really tell how far north or how far south it is at any moment, at any day. and therefore it's not a good indicator of which way north is, because it's not it's not coming from all the way northeast. Okay, so therefore it's not a useful method. Amar Shemuel is known to be an expert in astronomy, and we'll see how his depth of knowledge here. En tikufat nisan ofelet ela v'arba'a rib'e hayom, או בתחילת היום, או בתחילת הלילה, או בחצי היום, או בחצי הלילה. Okay, so תקופת ניסן, ניסן is spring, so that means the spring equinox, the vernal equinox, only occurs, the exact time of that is going to be either at sunrise, sunset, midday, or midnight. Right? Every year it might be a change and be one, but it has to be one of those. Falls out exactly. And so that, therefore, the next 3 months later, Entikufat Tammuz, in other words, the summer solstice, the longest day of the year, since that's 3 months later, so all this is based on a calculation that the year is 365 days and a quarter. So that quarter, 6 hours, over the whole year, right, it progresses another 6 hours. That means every 3 months, it progresses a quarter of that, which is an hour and a half. So if the spring started, let's say at sunrise or midnight, then the winter solstice is going to be in an hour and a half later than that. So that's why he explains, either at 1:30 or or 7:30, an hour and a half after sunrise or midday, ben bayom, ben balayla, night or day. So sunrise, sunset, midnight, midday, an hour and a half after that. And the fall equinox then is going to be an hour and a half after that, which would be either 9 o'clock or 3 o'clock, either in the day or the night. And therefore the winter solstice, the shortest day of the year, is going to be an hour and a half after that one, as is not ella nofelet ella or be'arba mechsa or be'aser mechsa, is going to be either 4:30 or 10:30. That assumes a regular day, 6 to 6. It actually will be calculated according to sha'ot zemaniyot, meaning relative hours, taking sunrise to sunset and splitting it into 12. Ben bayom or ben balayla. Okay. Okay, very interesting. And he has another principle. En ben tkufa l'tkufa ela tish'im ve'echad yom ve'sheva sha'ot u'mechesa. If you take 365 and a quarter and you split it into 4, then you get each season. And so therefore each season is 91 days and 7.5 hours. So since there's an extra half hour from it's not split evenly into an hour. So that therefore, in every season, the planetary, the constellations are going to move ahead a half an hour. What it means by this is that they associated every hour of the day with one of the 5 planets that they saw, and the sun and the moon. So that's altogether 7 luminaries in the sky that move around differently from all the rest of the stars. So if you take that and you start with like Sunday morning and you go Mercury, and that's the first one, and then you go through a cycle of 7, and then when you've done that, then you start the cycle again, and you do that for all the days of the week. So that this is a whole chart of which constellation kind of rules over every hour of the day. But because the seasons are not even with the hours, so every season is going to be pushed ahead a half an hour. Okay. Shmuel, another teaching of Shmuel about astronomy. If the vernal equinox happens to fall out during the constellation of Jupiter, in other words, that exact hour is, according to this chart, this is only a partial chart, but you could extend it to all the hours of the day, happens to be in Jupiter, then there's going to be strong winds that are going to break trees. And if the winter solstice happens at Jupiter, it's also not good luck, it's bad luck, it will dry up the seeds. And that's only when the new moon appears at the hour of the moon or in the hour of Jupiter. All right. Tanura Banan. Okay. Now we're going to move from astronomy to geometry. Tanura Banan Hamarbeya et ha'ir ose ota kemin tabla meruba'at vechozer umerabeya et ha'techumin ve'ose otan kemin tabla meruba'at. So if you have a round city and now you're going to turn it and you want to add the techumim, first you make it a square and then you add all the squares around it. So that you have an extra 2,000 on each side. In other words, here's the round city. You first turn that into a square, and then you add squares of equal size to all around it, and then in the corners as well. So you gain considerable amount of space where you can walk. And you should not measure from the middle of each corner, because then you lose the corners. Ela mevi tabla merubat shi 2,000 amma al 2,000 amma umanichan bekeren be'alachsona, which is basically the same thing, that you don't want to measure from here, but rather from the full corner. נמצאת העיר משתכרת 400 אמות לכאן ו400 אמות לכאן. נמצאו תחומים משתכרים 800 אמות לכאן ו800 לכאן. נמצאו העיר תחומים משתכרים 1,200 לכאן ו1,200 לכאן. Basically, if you do the math, what you have here is that since the hypotenuse is 1.4, approximately square root of 2, 1.414 times the side. So then, besides the 2,000 amot, you get another 800 here. And in addition to that, you get another 400 from here to here. So really, even though the city edge is here, and technically you only have 2,000, but because you're doing all this making corners, in addition to 2,000, you get an extra 1,200 just from over here, and an extra 1,200 on this corner, so you get quite a lot more. Okay, good. Yeah, that's what we just said. Amar Abaye, u'mishtakachat la b'matad havya tere alfe atre alfe. So this is based on a city that's 2,000 by 2,000, and it's when it was originally 2,000 by 2,000. Then you get all those calculations. Okay, Tanya. Remember, we learned all these Techum Shabbat, how far you can walk from the cities of the Leviim, because the cities of the Leviim, they get 1,000 amot around them as empty space, just nice to be pretty, and another 1,000 amot around that, which would be for planting the vegetables. So that's the cities. Limse mehen 1,000 amma migrash, nimsa migrash rabia v'ashar sadot uchramim. So Rabbi Yosef is saying, this Baraita is saying that of those 2,000 amot, if 1,000 of them are just migrash, in other words, open space, and so the calculation is that open space, the first 1,000 amot, are a quarter of the total. So somehow we have to calculate that this is going to be, in other words, the first 1,000 amot around here are going to be a quarter of the total added section. Now, if we do the math, it's not going to quite work out, which is the next question. Rabia palgahave. What do you mean a quarter? It's a half. You have 1,000, which is empty space. The next 1,000 is a garden, is for planting, and so that's only half. Half of it is empty space. Half of it is a garden. Why do you say it's a quarter? Amarava bar adam meshoha'a azberali. Rava says that the bar ada, the surveyor, explained it to me. The surveyor, he's an expert in geometry. He does this all day long, and he explained to me the math that the inner boundary is obviously going to be less area than the outer one. Right, the farther out you go, the more it's going to increase exponentially. So as follows. Let's assume a city that's 2,000 by 2,000. So this is the city itself inside, 2,000 by 2,000. Techum kama havya. So what's the entire amount of the techum? Is shitsad keranot kama havyan. Techum kama havya shitsad. Keranot kama havyan shitsad. It's calculating as follows. If this is 4 by 4, then you're gonna let's take this square, right? That's 4 by 4. That's 16 million square feet, and this is also this is 2 by 2. This is 4, right? Million square feet, and this is 4 million square feet. This is 4, and this is 4. Altogether, that's 16 million square feet for the sides, like a plus sign. And then the corners are also going to be 1, 2, 3, 4 corners, and each one is 2 by 2. So that's another 16 million square feet. Altogether, 16 plus 16 is 32 million square feet. So of those, right, of that 16 million, dal temanya de tchumin varba de kranot. If you take out the 2 plus 2 plus 2 plus 2 and the 1 plus 1 plus 1 plus 1 of the corners, right, so then you're taking out 12. So we said this is a total of 32 minus 12, so it's 12 out of 32. And you see that's, nimsa migrash rabia, that still doesn't work, right? Tefe mitilataninhu, that's still more than a third. It's not a quarter, even according to that calculation. So it helped. Now we realize that the inside techum is smaller than the outside techum, but it's still not a quarter. Okay, so but we can do a little bit more calculation. You know what? Add the city itself to the calculation, and then you get a total of, well, this is 6 across and 6, so that's 36 million. And so this would, and this square is 12. That's 12 out of 36. But even that is only a third, not a quarter. Akate tilta have. So that still doesn't explain. So what we're trying to do is explain this braita up here, because the braita said that the empty space, the first 1,000, is a quarter of the total. And now, so far, we only have a third, not a quarter. So how are we going to get that? So here's the answer. We weren't talking about a square city, but rather a round city. If you make it a round city, then it will work out. How much bigger is a square than the circle that's inside that square? Well, we made that calculation one time, right? Because a square is going to be 4 r, 4 times the radius, whereas a circle is going to be 3 times the radius squared. So it's 3/4 of it. So Rabia. So Dal Rabia Minaihu. So what we'll do is we'll take that inside and subtract a quarter from it. Peshu lehu tish'a. V'tish'a metilatin v'shita rib'a have. And so if we take this, we'll do it here. And so we take this here. This total of this. This is here 1,000, 1,000, and 1,000. Right? I mean, the city radius is 2,000. City diameter is 2,000, but the radius is only 1,000. So let's do the calculation ourselves. This entire side is 6,000 by 6,000. That makes 36 million. So that's the total is 36 million. Now, this part is, let's say this circle, right? This total circle is going to be 2,000 is the radius. So squared is 4,000 times pi, let's assume pi is 3, that's 12, right? 4 times 3 is 12. So this entire thing is 12. But we have to remove the inside of the donut. And the inside of the donut is pi, which is 1, times squared is still 1, times pi is 3. So that's 3,000. So 12,000 minus 3,000, you get 9,000. So this donut is 9,000. And the entire thing is 36,000. 9,000 is a quarter of 36,000. So there you go. That was that is the case that the Baraita was talking about, and that works out. Okay, so that's fun. And this actually works. So that means the donut is a quarter of the entire thing, including the city itself. Right, so just point that out. That has to include the city itself in the total that the donut is a quarter of. Okay, so that's one way of calculating it. And now Abaye has a second way. Abaye amar mashkachat aname b'mata dehavya alfa be'alfa. You can make a similar calculation if it's 1,000 by 1,000. This city, instead of 2,000, be only 1,000 in total diameter. We're going to go through the same process that we just did. In the end, what we're going to see is that you can make the same calculation, but in this case, you exclude the city itself, which really sounds a little bit better in the words of the Braita, because the Braita sounds like the migrash, the empty space, is a quarter of the entire extra besides the city. Okay, so let's just go through the steps here. So where the tchum itself is what we're adding is going to be 8. In other words, as follows: 1,000 by 1,000. First, we're assuming it's square. Then we're going to say it's a circle. So if this is 1,000, then this is 2,000. This is 2,000. This is 2,000. This is 2,000. This is the way that the Gemara does the geometry. First, it makes a plus sign. So that's 8 altogether. And then we're going to add the corners too. The corners are 4 times 4 is 16. And 16 plus 8 is going to be 24. So it's 24 total, besides the middle, which is going to be another 1 for 25. So that's and how many of the corners? 16. Dal arbat tchumin, arbat kranot kamahave temanya. And if we take the sides off and the corners off, then it's 8. Right, so we have now 8 out of, in other words, this here is 8, right? That's the part that's empty space. So it's 8 out of 24. Well, 8 out of, right, which is a total. 8 out of 24 is only a third. So that actually does not work. Til tavu, it's only a third. Oh, you were calculating based on the city being a square. But what we meant is that the Baraita is talking about a round city. And so that's a square is a quarter bigger than a circle. So if you remove a quarter, so a quarter of 8, now you have only 6. And 6 out of 24, that in fact is a quarter. Okay, so that would work out. And in that calculation, you don't have to include the middle of the city anymore. Okay, good. Rabina Amar Mai Rabia de Tchumin. So this is yet another way of calculating it. When he says a quarter, the empty space is not actually all around, but rather only as this, like in this picture, it's the tchum on this side, on this side, this side, this side, not the corners. And so based on that, this would be a quarter of the total. And that would work out well. In other words, that would be 8 from the 24 of the 36. This one is 2,000 big, right? So there's 36 total, and this is 8 out of 36. So that's a quarter. So that's 30. Wait, 1, 2, 3, 4, 5, 6 is 36.
9 would be a quarter.
9 would be a quarter. Wait, so how's he calculating this? Along the sides, but not as corner. A corner city has 2,000 cubits by 2,000 cubits at a total expense of 32 million. Oh, sorry, we're taking out the city itself. That's why. Okay, it's 36 total, but minus the city is 32. So the entire added space is 32, and 8 out of 32 is open space, and that is a quarter. Okay, good. Thank you. Rabashe says. He says that when we calculate this empty space, it's only the corners. It's the opposite of Rabina. Rabina said these spaces. No. These spaces, forget these spaces. This one, this corner, this corner, this corner, and that is a quarter of the entire corner, right? This is a quarter. This would be empty space is a quarter of the entire corner. That's how he's calculating it. All right, like this. Here's the picture. Okay, that's the open space, and that's a quarter. And you don't deal with the plus sign. Okay, Amar Rabina Rab Asher, Sabib Ketib. Rabina says mine is better because it says that the added space of the Levite city is going to be Sabib, meaning around. So that this doesn't look like it's around. Around means was more like what I said, right? Where you had more like the plus sign. My Sabib de Kranot. Rab Asher says, no, mine is also around. I mean the corners. See the corners? That's also around the city, isn't it? Tichtib vezaraku bnei Aaron et hadam al mizbeach sabib. When the Kohanim sprinkle blood on the altar, they put it on the corners, right? All the four corners, and yet it says saviv, meaning around. So you see, the word saviv can in fact apply to something being only in the corners. That's still called around. That's pretty good proof. Hachinami sabib mamash. So too, that's the same thing here. Ela mai sabib dekranot. Hachinami mas sabib dekranot. Okay. Amar dekranot. Amar lerab Habibi mehozna'a lerab Asher. Va'ika morsha dekarnata. Okay. Now we're going back to what we said before, that it's talking about a round city, according to Ravan Abaye, and he says, when you're talking about the round city, what about the corners? In other words, kind of assuming that if it's round, and if you would start the corners right at the edge of the circle, then you're missing out. And so, what are you doing with that? And Rav Asher says, no, b'mata igulta. We're talking about a round city. He seemed to not have understood that the questioner already assumed it was round city. So Rav Chavi says, no, no, but you're supposed to square it off. Okay, so now we clarified the question. Don't you have to square it off first? And then you'll be missing out. And what amrinan chazenan keman de mirba'a lebu'e vadai mi miraba'ana. He says, what you do is when you're squaring it off, it's only in your imagination that you add that extra space, but you're not building any houses in that part that you're squaring off. It's still empty space. So therefore, even though you're calculating the eruv not from the circle, but rather from the corner, and then you get another 2,000 amot, right, all ways. But still, when you're calculating empty space, this is still that empty corner is still added, still part of the empty space. So there's no problem here. Okay. Amar le, yeah. Mikadi. Right, that's what we just said. Amale, I forgot where we were. Okay. So now another question to Rav Asher. Mikti kama meruba yater al haigul Rabia hane temane mea shit umea v'shitin ushba neche tilta have. Amar le hane mile beigula migor ribua ava ba'alachsona. Okay, the question here was that we said a general principle that a circle is 3/4 of a square, and now if you calculate just the line of I don't have a good picture here. The line itself, then it's going to be for 2,000. What would be 2,000 amot, and so 1/4 of that would be 667 subtracted, and that doesn't add up. It should be 800. And so the answer was, when we say it's 3/4, that's not talking about a one dimension, but rather an area. This rule that a circle is 3/4 the area of a square is a calculation for area, not for the diagonal. And so the questioner was wrongly applying that formula to a one-dimensional line, and so he corrects him and says, no, it's for the area, and when we do it for the area, then everything makes sense. And so we'll stop here at this Mishnah, and tomorrow we'll make up an extra half a daf, and then we'll be right on schedule.